Imagine throwing a ball straight up. It goes up, slows down, and comes back down because of Earth's gravity. What if you threw it so hard, so fast, that it never come back? That magic speed is called escape velocity. Today we will learn what escape velocity is, the physics behind it, and the formula used to calculate it. We have seen that when a ball is thrown upwards, its velocity decreases because of the gravitation of the earth. The velocity becomes zero after reaching a certain height, and after that the ball starts falling down. Its maximum height depends on its initial velocity. According to Newton's third equations of motion, v square is equal to u square plus 2as. इसमें जो फाइनल वेलोसिटी ऑफ द बॉल वो ज़ीरो है, एक्सेलरेशन नेगेटिव है क्योंकि अगेंस्ट द ग्रेविटी है. अभी इन दिस इक्वेशन में ज़ीरो इज इक्वल टू यू स्क्वायर माइनस 2gs. तो मैक्सिमम हाइट इन दिस इक्वेशन u स्क्वायर इज इक्वल टू 2gs हो गया. तो हमको भी क्या चाहिए, s चाहिए. तो हाइट, मैक्सिमम हाइट कितना, तो s इज इक्वल टू माइनस यू स्क्वायर अपॉन 2g. अभी ए इक्वेशन हमको क्या बताते हैं, द मैक्सिमम हाइट रीच्ड बाय द ऑब्जेक्ट ओनली डिपेंड्स ऑन इट्स इनिशियल वेलोसिटी. जितना मैक्सिमम हाइट वो रीच करते, दैट ओनली डिपेंड्स ऑन initial velocity only. Thus, higher the initial velocity u, the larger is the height reached by the ball. The reason for this is that the higher the initial velocity, the ball will oppose the gravity of the earth more and larger will be the height to which it can reach. When a body is thrown vertically upward from the surface of the earth, the minimum velocity of the body for which the body is able to overcome the downward pull by the earth and can escape the earth forever is called the escape velocity. An object of mass m, the object is on the surface of the earth. When this rocket is launching, its kinetic energy is 1 upon 2 half m escape velocity square. Here in the potential energy minus gmm upon r, that means here h is not there because the object is on the surface of the earth. Total energy E1 is equal to potential energy plus kinetic energy. That is equal to half m escape velocity square minus gmm upon r. Now this object reach the infinite distance from the earth, that is the object will come to rest. That means its velocity also zero, and at infinite distance the gravitational constant is also zero. The kinetic energy, that means kinetic energy is equal to 0. At infinite distance, the potential energy is also 0. That means gmm upon infinity is 0. Now the total energy E2 is equal to kinetic energy plus potential energy, that is equal to 0. From the principle of conservation of energy, total energy at the earth's surface is equal to total energy at infinity. That means E1 is equal to E2. Now half mv escape velocity square minus gmm upon r is equal to 0. That means half mv escape velocity square is equal to gmm upon r. Now the escape velocity square is equal to 2 gm upon r. Therefore, escape velocity is equal to square root of 2 gm upon r. Dividing and multiplying this equation by capital R, the radius of the earth, then this equation will be 2 gm upon r square into r. Then this equation, that means escape velocity, is equal to square root of 2gr. If we substituting the values of gravitational constant 9.8 and the radius of the earth 6.4 into 10 raised to 6 meter, and we will get the escape velocity's value 11.2 kilometer per second. Important facts. Mass independence. Notice that mass of the rock cancelled out. Escape velocity does not depend on the mass of the object escaping. A feather and a spaceship need the exact same speed to escape Earth. Other planets. Mention that Jupiter has a much higher escape velocity, about 59.5 km per second, because it has more mass, while the Moon has a lower one, about 2.4 km per second. Black holes. Briefly mention that black hole is an object where the escape velocity is greater than the speed of the light, since nothing can travel faster than light. Nothing can escape it. Last minute revision. Practice it properly, students. This PDF link is given in the description box.